Hey guys, I'm Abby, and welcome back to One Code Camp channel. Today, we continue with our MongoDB series. We will learn all about aggregation. There will be a lot of things to tackle, so let's get started. Before we get started, it is important to note that we should already know the CRUD operation in MongoDB. If you don't know it yet, don't worry. We have separate videos for that, tackling each of them, so make sure to check that out before you dive into aggregation. If you already know CRUD, this is the perfect time to learn the aggregation framework because you will be able to relate in a much better way about how aggregation is much more powerful. Aggregation framework is an alternative to defined method. It is building a pipeline of steps that runs and passes to the next step. So it is much complex, but is more powerful than defined method. It has a series of steps, which we can refer to as stages. The series of steps that we will be having are input and output. So here, we will be having these series of steps where the documents will undergo execution of the series of steps. It will process multiple documents and will give us an output, returning us the computed results. First, before we dive into it, why do we use aggregation operations? First, it groups values from multiple documents together. It performs operation on the grouped data to return a single result. And it analyzes data change over time. There are two methods that we can use to perform aggregation operations. The first one is aggregation pipeline. This is the most preferred method for performing aggregations. The second one is the single-purpose aggregation method. This is much simpler, but it lacks the capabilities of an aggregation pipeline. Let's look into the aggregation pipeline. Aggregation pipeline consists of one or more stages that process documents. Each stage performs an operation on the input documents. The documents that are output from one stage will be passed to the next stage. So, for example, we have a document input where we want to find something. The result of that, the output, will be passed as an input to the second stage, and the output of that will be passed again as an input to the next stage, and so on until you get the final result or output. Let's look at how aggregation looks like. Here, we have db.orders.aggregate, and inside of that, we have two stages. This may look a little bit overwhelming, so let's see what's happening inside of here. This example that we have contains two stages and returns the total order quantity of medium-sized pizza, and it is grouped by pizza name. Stage 1 is match stage. This is similar to the find method. Here, it filters the pizza order to the pizzas of medium size. Once it finds the documents matching the medium pizza, it passes those documents that it found to the group stage, which is now the second stage. In the second stage, it groups the remaining documents by pizza name. Then, it uses sum to calculate the total order quantity for each pizza name, and the total is stored in the total quantity field returned by the aggregation pipeline. So that is one of the two methods that we can use to perform aggregation operations, the aggregation pipeline. You can have more than 2 steps, but that is an example for now. The other method is the single purpose aggregation method. This aggregates documents from a single collection. This one can be very simple, but that can also be a downside since the capabilities are very limited. We have actually discussed a few of these in our read operation when we chain one method to another. One example that we have mentioned before is db.collection.count. And as a review, it returns us a number of documents in a collection. Another one, this one we haven't mentioned before, is distinct. This returns an array of documents that have distinct values for a specific field. It gives us the unique documents that are available in that specific field. We will see more of these as we move further, but it's good to introduce it for now. Okay, now let's see how we can use these, and I'll introduce more operators along the way. Let's now look at how match and group work. Let's make a pizza place database. Then here, we want to create a collection, which we will name orders. Then we will insert multiple documents in here. So here we want the name. Let's call this pepperoni. And then we also want the size. So let's make it small. And then the price of 19. Quantity of 10. And let's make some more. Okay, so let's add it. So all of those are added now. And if we refresh, we pizza place database in here with the orders collection. All right. And previously, what we have learned is if we want to get the documents, for example, only those that are medium-sized, we use the find method. And we specify what we want to get. Right? So what we can do is db.orders.find. And then we specify here the size of medium. It would be in quotations and medium. Okay, and we only got those pizza orders with medium size. And now, in aggregate, we can get the same result using match. So that's .orders.aggregate and then array. And then curly braces. And we want to use match. What we want to do is specify the field, and we want the medium sizes only. Right, so there we got the same result. But maybe you might be thinking, why should we use the match aggregate if we are having the same result as the find method? Find method is a lot harder to type. Well, as we have mentioned earlier, aggregation will allow us to do more things. We won't usually just use one method in here. Okay, so let's do that. In our explanation earlier, we also used group. Let's see how that works. In group, we need to mention what values should be here. And we need to group it with the name. And whatever field you want it to be grouped by, we need to mention it as the ID. So in Aggregate, the ID means a little bit different. It will not be the unique identifier. Instead, it will be the field you want it to be grouped by. And I want it to be grouped by name, which is the name of the pizza. Then we want the total. And in here, we want the aggregation pipeline operators. And then we want the sum. Here, it will calculate how many medium orders we have for each pizza name. Now, we see that we have one order for each. This will be especially useful if we already have lots of orders, because for now, we can actually count it manually and there will be no problem. So let's add a few more documents so that we can appreciate it a little more. So again, we will insert multiple documents in here. Okay, we want, again, the pizza name. For example, somebody ordered a pepperoni pizza. And the size is medium. Then we will specify the price. It is, what's the price of a medium pepperoni pizza again? Okay, that's 20. And then the quantity is 5. And then we want to add some more. Someone ordered this time cheese. Then we want to specify what size of cheese pizza they ordered, which is medium. The price again, let's check that here. That is 13. And then the quantity is 10. Let's add another. This will be cheese again. And another one of medium. Price is 13. Oops. Okay, and the quantity is now 8. Right, so that will do for now. Okay, and then let us see that using find. Let's check those documents we have added. Okay, and let's see. Let us specify the size of medium. So here we have these documents. We have all the medium pizzas using find, and we can also use aggregate to have the same result using match. Right? It's the same as in find. Right, now we have vegan, cheese, pepperoni. Okay, and now let us make use of the group. So we want to group all the cheese, all the pepperoni. We want to see how many have ordered pepperoni, cheese, and vegan for those medium pizza sizes. Okay, so let's make use of the command that we have earlier. Let's clear this first, and db.orders.aggregate, and then we want to match it again. And again, we want to match the size of medium. You want to find all of those pizzas with the medium size. And then we will make use of group. Right, so group, and then curly braces. And then inside of here, we will again use ID to find or match it or to specify what field we want it to group by. Okay, so we want it to be grouped by name, right? Then what else? The total, which will be the sum. Okay, so I guess that is it. We want to see all of the medium-sized pizzas, and we want to see how many orders we have for each of them. Okay, so I have 2 orders of pepperoni, 3 for cheese, and 1 for vegan pizza. However, this isn't very useful. We want to know how many of each we will have to prepare. So let's put another field. So let's do that again, db.orders.aggregate. And then again, we want to match it with the size of medium. I'm typing this again so that we can practice the syntax. And then we want to group it again. All right, we want the ID, and we want that to be the name. Okay, we can also type it like this. So we have the label of pizza and then the name, and then the total, again, sum. And we can add another one in here, which will be the total quantity. And we want to sum all of their quantities. Okay, so that we will know how many of these orders we need to prepare. Okay, so we want to sum the quantity. We have an extra curly bracket here somewhere. Let's look at that. Let's check that again. It could be very confusing sometimes with all of these curlies and square brackets and parentheses. So let's make sure that that is correct. There you go. We now have the total orders and the total quantity for each of them, for each of the pizzas. So we have to prepare 25 medium pizzas for pepperoni, 68 for cheese medium, and 10 for vegan medium. You can also use this by using the small pizza orders, right? And that is how we can match and group our documents by name or any field you like. And if we check using the find method, we will see the total quantities for those pizzas as well. Okay, but it is not like the sum of everything. It's an individual thing for each. Okay, so here is how aggregate, match, and group, sum will be very useful. Okay, so the next one is project. What project does is it passes along the documents with the requested fields to the next stage in the pipeline. Let's see how that works. For this one, let's use a different database again. We will use the music library and use the albums collection. Currently, we only have one document here, so let's add more. Let's add 2 albums and then insert 1. So here we will add it one by one. We want the title. So for example, this is, again, I'm making this up. Let's see. Come Rain. I think I have that title somewhere else. But yeah. And then let us have the CD number, maybe. Okay, so let's add a bunch of random numbers here. Okay, and then I want the artist. So here we will add if they have a first name. So let's make up some names right here. For example, we will have, this should be a quotation mark, okay, Joe, and then last name of Amber, and then the middle name. Okay, and let's make this A or something. Okay, and let's add another field. Maybe let's make it copies. The total number of copies that the album has. Okay, so it is now added in there. Okay, so we have the artist. Okay, let's just edit this one. So we have the title. This one is Jesse. And again, a bunch of numbers in here. So I'm using this, making this as a string in case it will be a bunch of letters and numbers. The first name is Jesse. It will be a self-titled album. Last name is Claire. And we will leave the middle name empty. And the copies, 34. And let's add another one. This one, the copies, 62. And this one doesn't have a middle name. So let's completely omit that. Last name is Lambert. And the first name is Rhyme. Again, a different CD number, CD code. Okay. And then the title is, I don't know, scripted. Right? Okay, so there we have added those fields. We can check that using find. Check our documents. Let's clear this first, and then db.albums.find. Okay, so we have these 4 documents. This one is the one that we have created before. Okay, so now let's make use of project. So let's clear that first, and db.albums.aggregate, and then project. And inside of here, we want the title. We also want the artist. Okay, so this should be an object. Let's see that for now. I have a syntax error in here. Oh yeah, this shouldn't be a separate curly braces. Oops. Okay, and we are lacking one more, I think. Yeah, one more curly brace. All right, there you go. So now we see these fields that we have specified. Now again, ID is default. So if you want to exclude it, we can also specify it. Okay, so let's do that. Let's clear this first and do the same again. db.albums.aggregate, and then in here, project. We want the title, ID. We don't want the ID to be included. And then artist will be the first name. Okay, and there you go. We now only have the title and the first name of the artist. Okay, so we have an empty object in here because we don't have that title and artist fields in there. So maybe we can delete that for now. Okay, again, to delete, we use the delete one method, and we will specify what we want to delete. Okay, so the name of that is best of me. Right, now we have deleted that. And if we try to find the documents, we only have those newly created documents. And we can use the project again, this time excluding the previously created document that we have. Okay, so we can also write this in quotation marks and using the dot notation, and we will have the same result. We're having a syntax error in here because we have an extra curly brace. Okay, so there you go, we have the same results. So you can use those two methods of writing when you want to get the specific field inside another field. Now here, we have excluded the ID field by typing in 0 and excluding the other fields by not specifying it. Here, we can also include fields conditionally in project. Let's look at our documents first. For our first document, we have first, last, and middle name. Second one has middle name field, but it is an empty array or an empty string. Then the last one, there is no middle name field at all. Let's clear this first. If we just specify that we also want the middle name, it will show us an empty string for those that have the middle name field, but doesn't include anything. So what we can do is create a condition. We will say that if the author dot middle name is an empty string, we should remove it. Okay, so let's type that in here. So we want the title, we want the middle name, but here's the condition. Okay, so if equal, so we're making use of the theories that we have before. If it is empty, the middle name is empty. Okay. Then what we want to do is remove it. Okay, so that's for when the middle name is empty. But if it is not, so that's else, artist dot middle name. Okay, so I have a syntax error, so if shouldn't have that $sign. So here, if the middle name is an empty string, it completely removed it. Okay, so it goes the same with the album that has an artist without the middle name field at all. It will only show up when there is a middle name. So let's also try to include the first name in there. So there's the first name and the middle name for Joe, but for Jesse and Ryan, only the first name is there. Okay, so another thing that we do is take a specified number of strings from a field. What do we mean by that? Let's have an example. Okay, so let's clear this first. And again, bb.albums. dot aggregate. And then inside, we want to use project again. Right, and we want to make use of the CD code this time. Okay, so we will name it prefix. That's the label of this one. And then the substring, substr. And then what we want to do is we only want those from CD. We want to get the characters or the strings from CD, and we want it to be only from 0 index to the 3rd index. So now we only got the first 3 from the CD code. Okay? Then we can also add other fields. We can name it anything we like. So for here, let us make use of the last name. And we get it from the artist dot last name. Right. And then now we have those CD code that only has the first 3 and the last name of the artist of the album. And again, ID is default. The next one is unwind. Unwind deconstructs an array field from the input documents to output document for each element. What's going on? That's a little too hard to grasp, so let's see that in action. For this, we're going to use a different database again. Let's use our online shop this time. Currently, we only have orders and customers collection. Let's create an inventory collection and insert documents in here. Okay, so we will insert multiple documents. We will have the product name. So let's just name it ename. Okay, so for this one, let's just use shirt. Okay, and then we will have the size. Okay, so it will be small. And let's add another. This time it will be, well, shirt again, but or let's just make this an array so that will be easier. Okay, so this will be multiple sizes. That's small, and then medium, and large. And then for the next product, we have shorts. And let's add the sizes here as well. Okay, so for this one, going to be multiple sizes again. So that's an array, S, M, and L. Okay, so let's add another one maybe. Oh, so this should be an object. That's another product we have there. And let's add another one. That's ename. And for this one, it will be a jacket. And the sizes will be we'll have small and large and XL. Inside, go. Okay, so that will do for now. So let's add a couple more. So for this one, we have size of XS, S, and M. Okay, and this will also be different sizes. There you go, SL and XL. That's a little bit confusing. Okay, so this one for jacket is only small. All right. So we have added those documents right there. And let's check our inventory. So let's make use of aggregate. Okay, so here we have the jacket, 2 jacket documents, 2 shorts documents. And if we look at this, they are in separate documents, right? Even though we have jacket and another jacket, it is in separate documents. Okay, so it's also here. Let's just double check those. All right. Okay, so since we have different documents, but they have the same product name, we can group them. So earlier we have learned that we can group them by using group. So let's try that. So that's aggregate. So there, group. And then we want the name, all sizes. We will label this as all sizes. And we want to get it from the sizes, but we want to push it from there. Okay, so we will push those sizes inside of here. Okay, so, and if we enter that, okay, it only shows the sizes. Oh, yeah, I forgot. This should be ename instead of just name. So let's edit that one. There you go. We have grouped all the shirt documents, all the shorts documents, and the jacket documents. However, the sizes are in different arrays. So what we can do is use unwind to group them in a single array. So we'll use the same command as before. We will still group them. Okay, so these are in different arrays, right? Okay, so if we use the same command again, we can do that, but we need to use unwind first to deconstruct it. We will break it down to its individual parts, and only then we should group them. Okay, so first we will unwind so that they will be an individual parts. Okay, so what we want to unwind is the sizes. And after we have done that, we want to group them. Okay, so now they are together in a single array. But we have duplicates. Okay, so if we check here, we have S, S, L, and another L, all in the same array. So this will be even more confusing than the one that is grouped in different arrays, right? So what we can do is we need to get rid of the duplicates. So to do that, we can use the same command again, but instead of push, which just pushes whatever values are inside of the arrays, we will use add to set. And what this does is it will still push those values into the array, but if it sees the same value, it will not add it anymore, effectively making sure that there are no duplicates in this array and it will only have unique values. Okay, so here you can see that we have single S, single XL, single L, and single M for each of the products. Okay, we can add another pipeline in here. For example, we want to sort it. We can add sort and sort it by ID, which we specified as the name field in ascending order. Okay, so we want sort ID, which will be in ascending order. Oops, I have my curly braces all over the place. So let's fix that. Okay, let's check. There you go. So it is now sorted by name and everything is now perfect. And then the next one and last on our aggregate tutorial is bucket. Bucket categorizes documents into groups called buckets, and it is based on the specified expression and bucket boundaries and outputs a document for each bucket. So there are a lot of buckets going on in there, but let's go into it so we'll see how that works. Let's go back to our music library again. I'm going back and forth our databases so that I can show you the most appropriate examples for each. Okay, so here we have these bunch of song documents with random ratings. Let's use the duration as an example for now. So let's get rid of these first. We will use delete many method. And I want to delete the documents making use of the title field. And what I want to delete are those that have the word song in it. So all of these songs, song 1, 2, 3 until 100,000 is now deleted. So if we refresh this, we only have 8 documents in total. Okay, now I want to create new documents with a duration and rating field. So what this does is it will create 63 new documents with title, song then number 1 to 63, with a random duration from 141 to 203. And there will be a rating, and it will be random from 0 to 10. Okay, now if we check that, here we now have 71 documents in total. Okay, so that's song 1, 2, 3, and so on, and random durations and random ratings as well. Okay, and now if we use the dot find then dot count, we also see that we have a total of 71 documents because we have a pre-existing 8 documents. Okay, now let's use bucket in action. So that's db.songs.aggregate, and then inside will be bucket. Okay, so we want to group it by duration, right? Okay, group by, and then we will specify that using the duration. Then the next one is we will specify the boundaries. You can put lower boundary 1, lower boundary 2, and so on. So here I want to get the song durations between these boundaries. So I want to start from 148, and then I want to get 148 and 157. So that's between those two. And then I want to specify 158, 169, and 180. Okay, and we will have a default. Okay, so here, if we have other documents that didn't fit the boundaries that we have specified, they will fall under the default, which we named other. Lastly, we want to we want to show how it will look like, or the output. So I want it to show me how many songs are there inside these boundaries that we've made. So we want to count it, right? We want the sum. Okay, let's add some more later. Let's see how this looks like for now. Okay, now we have these counts. We have 18 songs from 148, 157, and so on. Okay, so now we can add some more details or fields. I want to know what songs are these, what are their titles and their durations. Okay, so I will specify that I want the title, okay, so we will get the title from our documents. And then we also want the duration. Right, and now if we hit enter, we will see those documents right here with those fields that we have specified. So if we try to take a closer look, the boundary starts from 148, and we have 148 in here. There you go. And that will be up to 157, since the next boundary is 158. And we have that here. Then 158 and 159, and the boundary will end in 168. But since we don't have a song with that duration, we got 167. Then we got 169. There next to that is 171. Since the last thing in our boundary is 180. We have those from 180 onwards, and those lower our first boundary and the others, which is the default. So here we can also make use of other fields like the rating. So if we create that boundary, we will be able to see it here. So this is 1, 2, and 3. Then the next is 4 and 5. Then the next boundary is 6. It will start from 6. And since we have other fields there, or other boundaries that didn't fall in our specified ones, it will fall under the other. And you can also play around with it, like having different boundaries. Okay, so let's make use of that. Let's experiment with other boundaries as well. So let's make it this 0, 3, 5, and 8, I guess. Okay, so we have other here. We have 5, E, and 0. So there you go. That is it for our MongoDB aggregation. That is quite a lot. So I hope you guys enjoyed and learned a lot from this tutorial. And we'll see you again in the next ones.